Today we are learning lessons 6, 1, and 2, starting chapter 6 out, which is a chapter on similarity. First lesson here involves a lot of math with ratios, proportions, something new for you in geometric mean, as well as how we can use kind of different proportions to solve geometric problems. Then we'll get into what is a similar polygon and how can we prove triangles similar in 6.4 and 6.5. Right? And then lastly, we'll end with different proportionality theorems we arrive at. So, if A and B are two numbers and B does not equal 0, then the ratio of A to B, it can be written as a fraction, A over B, or with that colon, A colon B, right? For example, the ratio of side lengths in the triangle on the left, all 2, to the side lengths in the triangle on the right, DEF, all 1s can be written as 2 to 1 or 2 over 1. Right? So a little note there, cannot be written as 2. It needs both numbers because we are talking about a ratio. So our ratios, even when simplified, need to have 2 numbers. Right? You wouldn't say the ratio of boys to girls is 3. Right? You would say 3 to 1 or 1 to 3. Ratios are expressed in simplest form, just like fractions. We would simplify. Right? So the ratio 7 to 14 and 1 to 2 are equivalent. So instead of writing 7 to 14, we would simplify and write 1 to 2, which in this diagram here would be the ratio of the width of our rectangle to the length of our rectangle. Next up, we're going to be simplifying. Now you can do this very easily, right? I generally write them as a fraction and just simplify the fraction. We have calculators that can simplify, right? 68 divided by 4. And then you can kind of do a easy fraction button. Now be aware, I need 2 numbers. So, yep, it's 17, but it would be rewritten as 17 to 1. Right? Or maybe you're really stellar at math and see that you can divide by 4 on top and bottom. All right, next one, 52 to 13. Also divisible by 13, divisible by 13, giving us 4 to 1. Both numbers are required. And then we got 21 to 91 down here. And again, this is where that fraction button can be helpful if you don't see you're divided by 7. Right, math button fraction. And we get 3 13. Right, divided by 7 is where that came from. And those are our simplified ratios, and again, or you can write this as 3 to 13. Plans to paint a mural on a rectangular wall, you know the perimeter is 484 feet. And the ratio of its length to width is 9 to 2. Find the area of the wall. Right. So in this situation, you always want to draw a picture. Instead of with rectangular, so I'm going to draw a rough rectangular shape here. It says the perimeter is 484, so maybe I'll just put that information inside. 484 feet. The ratio of length to width is 9 to 2. 9 to 2. So length to width is 9 to 2. Now this does not mean length is 9, width is 2. You could plug that in and realize, oh, it's not going to work. But it is 9 times some number over 2 times some number, right? It's generally where that comes from. So when I label my diagram, I'm going to label it that the length is 9x and the width is 2x. Okay. Next, it says find the area of the wall. Okay. So our goal is to find the area given that information. Right? Now, reminder, perimeter formula is 2L plus 2W, or I like to write it when we have the numbers as 2 times L plus W, because it's pretty quick for calculating. So plugging your numbers into either of those, right? Plugging our 2x is W and 9x is L, and P is 484, we can solve, right? So 484 equals 2 times 9x plus 2x, right? So we can either do this calculation or simplify. I'm going to divide by 2 on both sides. You get 242 is 9 plus 2x is 11x, right? You can add them together. So now I'm going to need a calculator one more time to divide by 11, and I get x is, that looks to be 22. That is not my final answer, right? Go back up. What are we looking for? We're looking for area. X is 22 is not the area. However, we have X in our picture in two spots, so we can calculate, right? Area of a rectangle is length times width. So we got 2 times 22 for our width, or 44, and 9 times 22, which is what? 198 is our length, and then we're doing that math of area equals the 44 times 198. You can use that on your calculator, giving us 8,712. And units squared, I believe it was feet. Yep, so feet squared. Remember doing area, it's units squared, which in this case, units is feet. Moving on, and again, if I'm ever noting too fast for you, just pause the video and finish your notes. Another one, I'd say we try this example on your own. It's the same idea. Perimeter of a room is 48 feet, rectangular room. Ratio of length to width is 7 to 5. Find the length of and the width of the room. So go ahead, try this one on your own. Now for this one, I will show the other way to simplify this, right? So this is our perimeter formula. We have 2, 5 plus 7 is 12x, so 2 times 12x is 24x is 48, and 24 times what is 48? X is 2. Now, slightly different answer because we're looking for length and width, so we need to plug in 2 to these two x's here and here, right? So 5 times 2 gives you 10. What's our label? Feet is our width. And then 7 times x, which x is 2, gives us 14. 7 times 2 is 14 feet is our length. And there's our answer right here. An equation that states two ratios are equal is a proportion. Right? Proportions commonly solved using the cross multiply and divide. So just a little note, B and C are considered the means, which that will be used for geometric means, and A and D are the extreme. Right? When you solve these, you generally cross multiply, AB equals BC, and then you can solve by division, right? If we have like 5x is 24, right, we could solve that with division. How do we solve? Just talked about this. Cross multiply and divide. 16 times 5 was 10 times x. And if you're a calculator person, right, you can solve the whole thing and just type my calculator into 16 times 5 over 10. 80 divided by 10 is going to give you 8. So what about if you have variables? Same rule exists. And again, why can you cross multiply? It's like multiplying both sides by 3y, but this side is going to cancel. If I multiply both sides by y plus 1, right, quantity y plus 1, this side would cancel and it would just be left over. So that's why it's like a cross multiply. We have 3y equals 2 times y plus 1. We're then going to distribute 2 times y, 2 times 1, that's 3y. Subtract 2y from both sides and get y equals 2. Doesn't hurt to plug it back in. 1 over 2 plus 1 equals 2 over 3 times 2, or 1/3 equals 2/6. Yep, it worked. A little quicker to check your answer than to find your answer. Next, the geometric mean is where your mean is the same number for both. Right, so the mean position were C and D, so C and D are both the same value, and so A and B are positive numbers of x, such that A over x equals x over b, so x squared equals AB and x equals square root of AB. So we kind of have some formulas here for us already for solving. So what's the geometric mean? Here's the setup, but we already have the solve process over here. X equals square root of 24 times 48. And that's literally what we would get to, right? If you cross multiply, you get x squared is a times b 24 is A, 48 is B. Square rooting, same spot. So generally how I like to do it is try to find some perfect squares here. We already have 24. 48 is 24 times 2. So instead of breaking down further, I have two 24s. 24 is going to come out. I only have 1, 2, so that's going to go back under. And my answer is 24 square root of 2. So 24 times square root of 2. A couple more examples of this. Solve for the geometric mean. Again, x equals square root of 12 times 17. Right? This one's not going to break down as much because 17 is a prime number. So we've got 4 here. And so 12 times 17 equals the same as 2 times 2 times 3 times 17. And you just need to find a pair that's going to come out. So I found a pair of 2s. One comes out. 3 and 17 are going to go back under and multiply. And we're going to get 2 square root of 51. How can you check these on your calculator? Might be a good question. Right? Plug in 2 square root of 51 and compare that answer to the square root of 12 times 17. Make sure both 12 and 17 are under the square root. 14.28285686. They both match. So those are equal. Lastly, 18 and 54. 54 is 18 times 3. So my 18 is coming out, and 3 is left under. Next up is we're moving on to lesson 6.2, which is more about properties of proportion. You might be like, wait a second here. You start at number 2, what's the first property of proportion? The first property is if AB equals CD, A over B equals C over D, then AD equals BC. We can cross multiply as the first property. So we've got 3 other properties. Now what we're going to do, because we're in geometry, is that we are going to prove where these came from, right? So if A over B equals C over D, then you can flip them. B over A equals D over C, right? Like, let's say we have 5, 8 equals 10, 16. Does it make sense that 8 over 5 equals 16 over 10, right? That works just fine, right? You just flip them and they still work, right? Next one, if you interchange the means of the proportion, so means are the bottom of the left, top of the right, so if you flip spots, then we're still true, right? So, yeah, these can flip position because we can still get AD equals BC. Right? Now, just a little note here. Generally, cross-multiplying is going to be how we are going to prove these. In a proportion, if you add the denominator to its numerator, you're going to form another true one. So A over B equals C over D, they're saying, what if we added B to the top here, added D to the top there, those would be the same. Right? So again, pick some numbers, see if it works. Let's say 2/3, and how about this time we'll do 6/9, right? If we added 3 to the top and 9 to the top, right, because whichever one it's got a denominator, we'll end up with 5/3. Does that equal 15/9? Yep, looks good to me. Okay. So we're going to be proving those. Use the first property to prove the others. So reciprocal, we're going to flip them. And again, the process is cross multiply. So I get AD equals BC, but now I want, like this is my given, for example, this is my proof. I want B on top. So what do I need to divide by? It's how this one goes, right? So if I want B on top, I'm going to divide by C on both sides. On the right side, or in this case my left side, I want D on top, so I got to divide by A. So we're going to divide by A on both sides and see what cancels out. And using red, I'm going to cancel, the A's cancel here, the C's cancel here, and we're left with D over C equals B over A, which is a little bit of a, I flipped my left and right, but those are equal, right? Symmetric property. 3 equals 7, or sorry, 3 plus 4 is 7, so 7 equals 3 plus 4, right? We can kind of switch which side of the equation is which without changing its meaning, right? If x equals y, y equals x. On to the next one, right? You can swap the means. So this one's a little bit easier. Again, this is given, prove. So again, we're just cross multiplying. AD equals BC. And now this time I want C on the bottom, so I'm going to divide by C on both sides. I want D on the bottom over here, so divide by D on both sides. And then what cancels? And I get A over C, let's do arrow, A over C equals B over D, and we match. Last one, right? Cross multiplying again, AD equals BC. Now you'll notice, oh sorry, we're actually not cross multiplying on this one, right? What's the difference between A over B, and I give mine up over here. Hold up. And we're switching this to A plus B over B equals C plus D over C. Yeah, because my first one is fine, but this is our proof fixed. And so what are we doing to switch, right? Simplify this for a second, right? This is the same as A over B plus B over B. Simplify this for a second. C over C plus D over C. I'm sorry, D over D. Fixed. A lot of mistakes, sorry. And this is literally plus 1, this is a plus 1. So both sides of the equation, we're adding 1. Addition property, add 1 to each side. How does that change? This side, we have B as the denominator, so we're going to make 1, B over B. And this side, we've got D as the denominator, so D over D. We get A plus B over B equals C plus D over D. That's when I had my proof right. But a little bit of working backwards, like what's the difference between the original and that? Was a plus 1, and so we just added 1 to both sides. Is there another way to do that one? Yes, but basically instead of, once you cross multiply, you'd have to add like AB or CD. You'd have to add a combination of both sides. Would be the equivalent of adding 1. In the diagram, MN over RS is NP over ST, write 4 true proportions. Now, we can technically solve for X, but we want to write the 4 true proportions. So fill it in first. So this is our first one. The given one's true. And again, the first step was that we could cross multiply, right? MN times ST equals NP times RS. The second one was we can flip. So RS over MN equals ST over NP. That's a reciprocal. The third one was we can flip our diagonals here and here, looking at that first one. So MN over NP equals RS over ST. And the last one was adding the denominators. Now, for this last one, I'm going to substitute the numbers in at the beginning. Or sorry, we'll do it second. But I want to show you, again, numerically how that it works. These all still truly work. We've got, going back to original, MN plus RS, right? We're adding the denominator equals NP plus denominator ST over ST. Now filling in the numbers, right? MN is 8. RS, NP is 4. RS is 10. ST is X, or 5, right, if we solve for it. So 10 times 4 equals 8X. That's where X is 5 comes from. Right, plugging into these other ones, we've got 5 over here, over 8 equals 5, RS 10. 10 over 8 equals X, which is 5 over 4. True. MN, we got 8 over 4 equals 10 over X, which again, you know, X is 5, right? And then the last one, 8 plus 10, 18 over 10 equals 4 plus 5 over 5. 9/5, right? And this means what? 18 tenths equals 9/5. Check. And we started with 4/5 is 8 tenths. I flipped them. 8 tenths is 4/5. All right, those are all true statements. Once you fill in the number. So a couple ways we can solve before we wrap it up. In the diagram, BD to DA equals BE to EC, find BA and BD. Okay. So they're saying this value, we'll call it Y. So we've got, because it's BD, we'll just leave it at BD. BD over DA is 3. I'm filling this in, by the way, so it's like, where are you at? Equals BE, 18, over EC, which is 6. We've got a rule here. We can multiply by 2. So what times 2 is 18? BD is 9. You can also do that, looking for your rules and your proportion as well. Now, if this one is 9, what's 9 plus 3? X equals 9 plus 3, which is 12, is BA. Last one, find AC. Right, so in this case, we haven't got this proportion yet, but 18 to 12 equals 18 plus 6 over AC, right? We're comparing sides and triangles. So again, we can also simplify. I like to show that part. 18 over 12 is 3/2, so 24 over what number equals 3/2? Rule of times 8. 2 times 8 gives you AC is 16, or again, you can always multiply to divide. Last one. This is kind of a proof that's going to creep into the next lesson. But given A1 equals KA2, B1 equals KB2, C1 equals KC2, how can we show that K equals A1 plus B1 plus C1 over A2 plus B2 plus C2? Now, first off, you're going to solve each P. We're going to say A1 equals KA2, and we're going to build off of this one. So I'm going to give it some space. Take one, and I want to build. How can I build this left side, or sorry, the numerator? I'm going to add B1 and C1 to both sides. Okay. Now, my left side looks pretty close to the numerator. Now I need to kind of build the denominator, right? How can I get A2 plus B2 plus C2? Well, B1 over here equals KB2. So we're going to substitute. C1 over here equals KC2. So we're going to substitute. So now when we substituted, our right side is now KA2 plus KB2 plus KC2. It looks pretty close to what we have in the denominator, but everything's got a K. So what we need to do is take the K out of each P. Right? This is like backward distributive property. I call it greatest common factoring, where if we take K out, we've got A2 left, plus we've got a B2 left, plus we've got a C2 left. And now that we have that matching here, right now I'm bringing back the left side, A1, B1, C1. And when I divide by this, parentheses on both sides, we get A1 plus B1 plus C1 over A2 plus B2 plus C2 equals K. That wraps up this lesson. As always, let me know if you have any questions.